Hi everyone, Mrs. Belo here. In this video, I'm going to be going over the Chapter 2 notes, slides 33 to 40, over the concept of density. So you guys are used to seeing mass being measured in grams and volume being measured in usually milliliters. And those are examples of extensive properties, right? Because mass, that depends on the amount of substance present, and same thing with volume. However, you can also have what we call derived units. So these are units that are made up of more than one base unit. For example, we have centimeters cubed, so that is for measuring volume as well, okay? That's just another way to see it. So cm cubed, these two are actually equivalent to each other. Speed, meters per second. And then area, for example, can be like meters squared. Now, density has derived units as well. And the most common one we're going to be using is grams per milliliter. It also can look like this as well. So that is how many grams you have of a substance per volume of that substance. And density is unique for every single substance. And density, this is actually an intensive versus these two are extensive properties, because density, it doesn't change with the amount of substance present. If you have water and you have, 5 gallons of water versus 5, cups of water, water's density is always 1 gram per milliliter. Like, the density of water doesn't change with its amount. So that's why density is an intensive property. And again, these are the most common units we're going to be using in this class. Are grams per milliliter. Usually we write them next to each other like that, but this is also visually what we're saying is how many grams do you have of that substance per milliliter. So here's always a fun question. What weighs more, a ton of styrofoam or a ton of bricks? Kind of like a ton of bricks or a ton of feathers. The answer is they weigh the same, okay? You can see here on this balance that they both weigh the same. They are both a ton, 1 ton. So they both weigh the same. However, the brick is denser than the styrofoam, so that's why there's more styrofoam. In a brick of styrofoam, there's a lot more atoms compacted into that area compared to the, this is not proportional, but just to illustrate, in comparison to the styrofoam that has less atoms. So if you want the weight, the mass, or the amount of atoms to be the same, then you have to have more styrofoam, because styrofoam is less dense than a brick, so you need more of these to balance out with how compact this brick is and how many atoms are inside of that one brick. Another way to visualize the same idea is if we're comparing two different those are two different substances, but let's compare two metals to each other. So copper is more dense than aluminum, okay? So copper, that is denser than aluminum. And you can see, because these atoms are close together, versus you can see here, these atoms are farther apart. Kind of like the same idea that we talked about with solid, liquid, and gas. We're just comparing two solid metals to each other. And again, this is where we can start to visualize density. It's, as the name suggests, how dense is something? How many atoms are compacted into an area? And if you have more atoms compacted into an area, the more dense the substance is. If you have less atoms compacted into an area, the less dense the substance. So that's copper and aluminum. Another example is aluminum and gold. This is just another way to weigh two different substances, is with this type of tool. So now I'm going to get more into, so up here in this example, both of these had the same volume, meaning they took up the same amount of space, but it's very clear that the copper has more atoms and this has less atoms. So the copper would actually weigh more. Versus this problem here, this example, I'll get back to with this example here. So if you have two objects that have the same volume, meaning they're both taking up the same amount of space, it's very clear that the gold cube is more dense than the aluminum cube because there's more atoms in this amount of space in comparison to less atoms in this amount of space. Again, they have the same volume, they both are taking up the same amount of space. It's just that the gold has those atoms closer together, so it has more atoms in that given amount of space. Again, density is mass per volume. How much mass, how many atoms do you have in a given amount of space? And the gold in this case has more. Let me go back to this example here, which is very similar to the ton of styrofoam and ton of bricks idea. So both of these have equal masses, okay? So they both weigh the same, just like the ton of styrofoam and the ton of bricks. So like these are both, I don't know, let's say 5 grams or something like that, okay? So they both weigh the same, okay? However, it's harder to tell with this example, but the aluminum in this case, because we already know this from the previous problem, but the aluminum is less dense than the gold because it has a bigger volume. It's taking up more space. Again, this gold, the atoms are so compacted with each other in comparison to the aluminum. The aluminum, they're a little bit more spread out. Here, let's do this actually proportionally. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So in order for these guys to have the same amount of atoms, okay, and to weigh the same, so let's say 5 grams, the aluminum, because it is less dense, it needs to be bigger because it has less atoms per volume in comparison to the gold. So we need to kind of like blow that up and have a larger volume of the aluminum so we can get more atoms in that space to equal out with the atoms of the gold. Again, the same idea, kind of similar idea applies with states of matter and how temperature can affect density. Now, we can really only talk about this if we're talking about the same substance, okay? So if we're comparing the same substance in comparison. Up here, we were comparing 2 different substances. So let's talk about just the same substance. So the more spread out the atoms or molecules, the less dense the substance. So for example, gas, like I don't know, nitrogen in its gas form would be much less dense than liquid nitrogen. And that would be, liquid nitrogen would be less dense than solid nitrogen. That's just an example of an element I picked. And that makes sense because solids, right, the atoms are closer together. Liquid, they're a little bit farther apart. Gas, they're very far apart. So if you're talking about the same substance, it's gas. The gas form will be the least dense. the solid form will be the most dense, and then the liquid is somewhere in the middle. However, not all substances follow this rule. For example, water is a really good example. Think about it for a second. Liquid water, that's liquid form, right? But ice, which is solid, floats on water. That's weird. That doesn't go with what we just talked about up here. So water is, you'll find out in this class, we'll talk about a rule, and then there will usually always be some exception to, sometimes there's like an exception to the rule. Almost always. Like we'll talk in this class, okay, these things are like this, but then there's maybe some things that don't follow the rules. Water is a really good example, right? H2O, water. And that has to deal with how water bonds. In this solid form, this is what it looks like. You can see that this is less dense because the molecules are more spread out because of how they're bonding with each other in comparison to liquid water, which is more dense. So again, there's some exceptions to the phases of matter, solid, liquid, gas. But typically with most substances, the solid is the most dense, followed by the liquid, and then followed by the gas being the least dense. However, these are other exceptions as well. So not just water, silicon, germanium, gallium, arsenic, and bismuth. All right, last is a little bit of a brain teaser. So number 1, that is in, so we have 5 different liquids, and I want you to try to figure out which is the least dense and which is the most dense by putting them in order. So is number 1 least dense or most dense? Pause this video and see if you can figure this out. All right, I'm going to go ahead and go over the answer. So it looks like the least dense is number 1 because if you look at the rest here, actually let's start with the most dense. I feel like that makes more sense. So the most dense is going to have to be number 2 here because you can see 2 is below 5 and 5 is below 3. And 3 is below 1. And then, yeah, so it has to be number 2. So that means, yes, the least dense is going to be number 1. And then that's going to be followed by number 3, because 1 is less dense than 3. 3 is more dense than 2. And then 2 is more dense than 4. And then, so 2, 4, and then 5 here is going to be less dense than number 2. But 2 has to be, hold on one second. Oh, I'm sorry, 2 doesn't go there. So 1 has to be the least dense, followed by 3. And then 3 is less dense than 5. And 5 is less dense than 2. And then 2 is less dense than 4.